us do convolution modulation. It's one of the critical property. In fact, a lot of complicated analysis. It is not just convolution, it is circular convolution. Please remember, which is called circular convolution. So what this property says, as in signals and system we discussed, convolution in time domain is multiplication in frequency domain. It's a DFT. Convolution in time domain is multiplication in frequency domain, but in DSP it is circular convolution in time domain is multiplication in frequency domain. IDFT of x of k is x of n is nothing but 1 by n, k equal to 0 to n minus 1, x of k e power j 2 pi k n by n. This is your IDFT form. Now what I am going to do, x1 of k into x2 of k. If x of k there, then x1, x2 there also x1, x2. Repeating 1 by n, k equal to 0 to n minus 1, x1 of k into x2 of k, e power j 2 pi k n by n. X of k, even here also x of k, x1 into x2, x1 into x2. Very big calculation, careful. Summation k equal to 0 to n minus 1, I have it changed. This x1 of k, let me write its DFT formula. What is general DFT formula? Summation n is equal to 0 to n minus 1, x1 of n, e power minus j 2 pi k n by n. What is its formula? It is its DFT. Same I have to write its DFT. Whose DFT? x2 of k is DFT. And then the last term e power j 2 pi k n by n. Now there is an important issue. In the existing formula, I do have small letter n, which again I can't use. I'm sorry, I can't use. So then what to do? Use some other variable. Let us take m. Because the same formula I can't have two same variable in two places, which represent two different concepts. Then is it applicable for here also? Obviously. What is its DFT command? Summation. I can't use m. I can't use n. Let us do some other. P is equal to 0 to n minus 1. x2 of p e power minus j 2 pi kp by n. So two DFTs inside your IDFT. Now let us do some change of summations. 1 by n, keep it pending, let us not disturb. This term, summation m is equal to 0 to n minus 1 x1 of m. This term, summation p is equal to 0 to n minus 1 x2 of p. Another summation is pending. Summation k equal to 0 to n minus 1. This term outside, this term outside, this summation inside. Still who is remaining? There are 3 e power j's. Okay. Let us merge all e power j's. E power j 2 pi, k is common, am I right? Minus m minus p plus n divided by n. So So now, can I do n cancel? Its value is 1. No sir, because there is no capital N here. No sir. In case, if, be careful, minus m minus p plus n whole term if is equal to n, can I cancel it? So I replace this by n. Yes, obviously n cancel, its value become 1. Not only that, 2n also, 3n also, multiples of n, it will give the same. Let us say qn. So what is that? I am going to replace this whole term by qn. Now just give a conclusion. N and n cancel. Who is remaining? Q. This whole term is not there. N and n cancel. Q. Q multiples of k, multiples of 2 pi, answer is 4. Nothing wrong. So keep it pending. Under that situation, let us do what is minus p qn minus n plus m. Take q value equal to one simple number. Reason is that minus 1, purposely I am taking minus p minus n plus n. You may ask why sir you took minus 1, why not plus 1? Because I need minus. Therefore p is equal to n plus n minus m. So what I am going to say, if I substitute this value in this place, then by default I should substitute this value in this place. Am I right? 1 by n, m is equal to 0 to n minus 1 x1 of m, x2 of who is p, n plus n minus m, don't have a doubt. Sorry, we did a lot of mistakes. What is this term? What happened to this term? What happened to all the term? If I substitute this term by this term, under that situation, I should also substitute this p. Am I right? Any p or only this p? Only this p. Not many p, only this p. Under that situation, what this p says? P varies from, it can take any value from 0 to n minus 1. Wrong statement, p varies from any value. No. You should take only one value. So what is the meaning of the summation? It is going to take only one value. Which value? That value. So the moment I substituted this p here, the summation is no more. So 1 by n is here, summation is here, x1 of m is here. This is no more because it says many p value. I substituted one p value. Recall. When I substitute here, I should substitute here. When I substitute here, n cancel. What is its value? 1. Summation 0 to n minus 1, 1. Add 1 plus 1 plus 1. Automatically, you know this formula. Answer is here. N and n cancel. Who is he? Summation m is equal to 0 to n minus 1. x1 of m. x2 of n minus m double bracket n. Am I right? Therefore, is it not resembling your convolution? Yes. I am going to do proof now. S1 of n. Circular convolution with the x2 of n. Hence proof. Okay. Let us do next property, modulation. Multiplication in time domain. x1 of k, circular convolution, x2 of k. This is the property. Convolution in frequency domain, ulta, reverse, is multiplication in time domain. Whenever you multiply two signals, it is something like carrier and the message, so we call it as amplitude modulation. The same concept, so it is called a modulation. Extra 1 by n, because that is the speciality of IDFT format. Let us start from LHS. It's a DFT, okay? Let us start from DFT of these two terms. DFT of x of n, let me repeat the same. DFT of x1 of n into x2 of n. I started from LHS, am I right? equal to summation n is equal to 0 to n minus 1 x1 of n x2 of n e power minus j2 pi kn by n equal to summation n is equal to 0 to n minus 1. Can I write its IDFT? Yes, sure. What is IDFT formula? 1 by n summation k equal to 0 to n minus 1. I hope you should tell me that is a change set. Okay. Is it flashing to you? Kn by n. But that it's flashing. I can't use the same variable k, you know. I have to substitute its IDFT. And the last term is minus j2 pi kn by n. Please recall, already one k value is there. So I can't use the same k value. Yes? So let me change the value as usual. Let us make it as m. Let us make it as m. Let us make it as m. And what is its IDFT? Can we make it as the same variable p? Good. 0 to n minus 1 x2 of p e power j2 pi p n by n. Come on. Take it outside. 1 by n. M is equal to 0 to n minus 1 x1 of m. I hope this term. Next this term. Another 1 by n. Two 1 by n's are there. P is equal to 0 to n minus 1 x2 of p. This term it will go inside. N is equal to 0 to n minus 1. There are 3 e power j's. E power minus j2 pi small n outside by capital. Who is remaining? Minus m minus p. Sir, there is plus p, but I am taking minus outside, so minus. So what about here? Plus k. Can I do n cancel? No. Now the same story, recall. If minus m minus p plus k, if it is n or it is qn multiples, under the situation, if you replace as this particular value, what is it I am going to replace? This by your qn, then n and n cancel, q is an integer, n is an integer, multiples integer, 2 pi is answer is 1. Under that situation, what is now minus p, put that side, qn plus m minus k. Let us take q equal to minus 1, same as before. Minus p equal to minus n plus m minus k. P equal to n minus m plus k. Recall, if you substitute this value here, then definitely you should substitute this value here. That says, this p can take only this value, it cannot take all value. Then who is the result? 1 by n into 1 by n summation m is equal to 0 to n minus 1 x1 of m. Cannot take all value, no, it can take one value. Which value? That value. N minus m plus k. This whole term become cancel 1. Summation 0 to n minus 1 is n. This n and this n is cancelled. So still one more n is there. I need, you know. 1 by n. M is equal to 0 to n minus 1 x1 of m. x2 of k minus m double bracket n. Is nothing but 1 by n, which is resembling your convolution x1 of k, circular convolution x2 of k. Hence proof.